Hello good dear viewers. In this tutorial we are going to find a solution to this nice geometry question. The question is not written on the board because it is too long, but let me state it. What the question was saying is that we should prove that the area on this big semicircle, the sum of the area of this C and B. And that's just the question. But if you observe, we have a right angle triangle here. Okay, let's get started. To find the area of a cycle, you need the radius. And the area of a cycle divided by 2 will always give us the area of semicircle, because semicircle is half of a cycle. So since we don't know the length of these respective sides, let's call this one A, let's call this B, let's call this C. Therefore, A stands for the diameter of the bigger semicircle, B, C, respectively. So let us first of all find the area of this big semicircle. It is going to be for, let me say for A, it stands for the area of this. It is equal to half, because we have to divide the area of a cycle by 2. Therefore, half multiplied by pi, then multiplied by r squared. But what is our r? R will be A divided by 2, because diameter divided by 2 is equal to the radius. So we have A divided by 2 whole squared. So this is what we need to simplify to obtain this area. A to the power of 2 is A squared, 2 to the power of 2 is 4. So we have 2 here multiplied by this 4, it is going to give us 8. So altogether we have A squared pi over 8 as the area of this big semicircle. We're going to do the same thing for all. For the B, it will be half pi. What is the diameter? B divided by 2 squared. Simplify this, you're going to obtain B squared pi over 8. And for the last one, this question is very simple. For the C part, this is equal to half pi, then the diameter is C, divided by 2, we get the radius, r squared. Multiply everything, you have C squared pi over 8. So these are their respective areas. But we want to show that, okay, this is C, sorry. We want to show that this particular area is equal to the sum of these two areas. But how can we do that? Remember our Pythagorean theorem, which stated that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. For instance, if this is our acute angle. So A squared from here will be equal to B squared plus C squared. And we can also call this, we have two. This is an equation. Remember, if you are multiplying an equation by anything, you have to multiply every single term. And I observe the only thing we can multiply this to make it equivalent to all of this is what? Pi over 8. So let us multiply, I don't have space, multiply by pi over 8 all through. If you multiply this by pi over 8, you have A squared pi over 8. Do the same thing for all of them. So far the value is the same thing, the equation will remain balanced. So we have B squared pi over 8 plus C squared pi over 8. Can you see that if you should relate this to all of these areas, you can see that this stands for the area of the bigger semicircle, this stands for the area of this other semicircle, and the last one stands for the area of this, and hence the area of the big semicircle is equal to the sum of the two areas of the other smaller semicircles. And this is all I have for you today. Thank you for watching. Ensure to like this video and share to your learning colleagues. Bye bye.